Welcome to the course Business Analytics and Data Mining Modeling using R. So, in the previous lecture we concluded our discussion on KNN, K nearest neighbors. So, in this particular lecture we are going to start our discussion on naive Bayes. So, let us start our discussion. So, before we go into the naive Bayes, let us discuss the complete or exact Bayes. So, which is the basis for naive Bayes modeling. Complete or exact Bayes specifically for classification. So, let us get down the steps that would be required. So, you would see there is some similarity in the steps with KNN algorithm. So, in the complete or exact Bayes for classification task, so first step is search for records in the training partition having same predictors values as the new observation to be classified. So, in this case depending on the number of predictors that we have in our data set, 3-4 predictors depending on the number of predictors, for all those predictors the value that new observation is having of those predictors, in the training partition we have to find out all such records which are having the same value as the new observation to be classified. So, the values should be same. So, there has to be the exact matches. So, the values predictors values for the new observations, right. So, we have to find records in the training partition which are having exact values for all those predictors. So, so that is the first steps. So, we need to find out all such records in the training partition which are having the same predictors values as the new observation to be classified. So, this being the first step. So, once we have the list of all such records, then we can find the most prevalent class. We are discussing this for the classification task. So, therefore, the outcome variable of interest would actually have the classes. If it is 2 class scenario, we will have class 1, class 0. Otherwise, M class scenario we have more than 2 classes. So, we will have to find the most prevalent class of the outcome variable among the records. So, the records that we have listed down in the step number 1, first step. So, among those records we will have to find out the most prevalent class of the outcome variable. Now, this particular class is in the third step. As you can see, this particular class is going to be assigned as the class of new observation. So, you can see there is a similarity between in terms of steps. So, with the KNN approach. So, KNN approach also we talked about very simple steps there we had finding doing the computations between the new observation and the observation in the training partition, right. Then then the searching for the K nearest neighbors, and then looking for the most prevalent class and then assign it to the new observation. Similarly, here we look for the within the training partition we look for the records which have the same values for the predictors values. There we used to compute the distance. Now, we are interested in finding the records having the same values as the new observation, and again the next step is same, and then finding most prevalent class within those identified in the step 1, and then assign that class to the new observation. Now, as we talked about the class of interest scenario, which is different from the usual or typical scenario where we focus on the overall misclassification error, overall error, we would like to minimize that, and we do not have any preference for a particular class. So, that is the typical scenario, but sometimes we might be interested in a particular class. We would like to identify the members belonging to that particular class. So, we have a class of interest. Then in that case, as we have been talking about in the previous techniques in previous lectures as well, that the user specified cutoff value for the class of interest has to be established first. So, first we need to establish this particular cutoff value. So, that will depend on our expertise and the level of misclassification error that we would like to tolerate for other classes, and still be able to identify more number of records belonging to the class of interest. And if the class of interest also happens to be a bit rare class, then the situation for the cutoff value would also be more more expertise would actually be required to get that value established. So, we need to establish this value first. Then the next step is going to be search for records in training partition having same predictors values as the new observation to be classified. So, this step is same as the in the previous approach where we go by the majority decision rule or the most prevalent class. So, this step is same. So, we have to again find out the records in the training partition which are having the same predictors values as the new observation. So, once this list is known to us, then we can find the probability of a record belonging to the class of interest among these records we have, among the list that we have identified. So, within the list identified in the previous step, we can look for the probability of belonging of a record belonging to the class of interest. Then as we discussed in the Canaan and even before that, this probability value computed probability value for the identified records, right, this will be compared with the cutoff value, user specified cutoff value, right, from the step 1, and if it is greater than that, then the new observation is going to be assigned to the class of interest. So, these are the two approaches. One approach is where we have the equal cost and or we do not have the class of interest, then simply the most prevalent class. If we have a class of interest, then we have to specify the cutoff value, then we will have to also focus on computing the probability value of belonging to that particular class of interest, and then compare these two numbers and then do our assignment of classification, assignment for classification. So, these are the steps in. So, these steps that we have talked about, they are for the complete or exact base. So, till now we have not started our discussion on naive base. So, we have started our discussion on the main the main principle, main base principle, that is for complete or exact base. Now, for the complete or exact base, the two scenarios that we discussed, the regular scenario and the class of interest scenario, in both those scenarios, we have been the underlying probability related concept is the concept of conditional probability. So, for an outcome variable with m classes, so C1 to C2 to up to Cm, and p predictors from x1, x2 to xp. So, we are interested in the following probability value. So, probability of a particular observation belonging to class I given the predictors p predictors values x1, x2, xp, given these values. So, conditional on these values x1, x2, xp, we would like to find the probability of a record belonging to class Ci. So, we are interested in this these conditional probabilities value in both the scenarios. Now, in the scenario number 1, which is the regular scenario, typical scenario, where we are interested in minimizing the overall error, right, then in that scenario we would like to assign the new observation to the class with highest probability value, right. In the other scenario, so the value would be computed using the this conditional probabilities, right. So, so what the steps that we talked about before, so that has been expressed in this probability value format. So, we need to compute the probabilities value using this conditional probability for all the classes and given the predictors information, and once that is done, new observation can be assigned to the class with the highest probability value in the regular scenario. When we have the class of interest scenario, then if the probability value for the class of interest is greater than the cutoff value for the same class, then assign the new observation to the class of interest. So, main idea being that the conditional probability, when we talk about finding the records in the training partition which are having the same values as the new observation, then essentially we are looking to compute this probability, because in the next step we would be finding the most prevalent class or the class having the highest probability value. So actually the probability value would be the conditional probability, and using this particular expression. Now, as you might have understood by now that the predictors that we have to that we are going to include in our base modeling, they have to be categorical. So, in the for example, in KNN or other classification, other techniques which could be used for the classification task, generally the predictors could also be the continuous variable, but in this particular algorithm, in the base model, the predictors should also be categorical. It's not for the classification task, not just the outcome variable has to be categorical, even the predictors should also be categorical. If they are numerical variables, then they will have to be converted into categorical variable through binning. So, if we are going to use naive Bayes modeling or Bayes modeling in general, then all the variables, whether the predictors or the outcome variable, all of them they should be categorical. If they are continuous, then they will have to be converted into categorical variable through binning. So, this is an important difference. So, the techniques that we are going to cover in this course, this is a one particular technique which has such condition which requires all the predictors to be categorical. So, therefore, from this you will also understand that Bayes modeling cannot be used for prediction task. So, this is mainly it can be used it is used for the classification. So, even though theoretically we can apply Bayes model for prediction task, but it would be very difficult for us to find records in the training partition which would be having the same values as the new observation, right, especially for the prediction task. It is going to be very difficult to match the numeric values of a new observation with the records that are there in the training partition. So, very difficult to get those matches, and therefore, this particular difficulty can increase multifold as the number of predictors increase, right. So, even if there is one mismatch, that particular observation cannot be selected for further steps. So, therefore, it becomes impractical to apply Bayes model for prediction task. So, most of the discussion that we are going to do in this particular topic, naive Bayes and overall Bayes as well, because right now we are discussing the complete or exact Bayes. So, would be around the classification task, and therefore, whether it is the predictors or the outcome variable, both have to be categorical variable or converted to categorical variables through binning. So, what we will do, we will do an exercise using Excel. So, where we will apply the complete or exact Bayes and see what are the issues that we might encounter and how it can actually be applied on a real problem. So, let us open this Excel file. So, this particular example is about this is audit data. So, this is for the financial firms are required to submit some of the financial documents, some of the financial statements to regulatory bodies for further inspection, right. Before that they are required to get their audit done with the accounting firms. So, for the accounting firms, they have to use a lot of their human resources and other resources, systems and analytic solutions and softwares to analyze the financial statements, the financial reports submitted by their clients, and because they have a big incentive to find out the fraudulent statements, fraudulent reports, otherwise they are going to be penalized. by the regulatory body. So they are required to certify that those firms have all the legal reports, legalized reports. So the responsibility lies with them. So therefore, it is very important for them to find out the fraudulent reporting, any erroneous reporting. So therefore, if a firm has some information, because if they have loyal customer, loyal clients, so they might also have information about the previous such reporting, previous such previous troubles, that the legal troubles that might have occurred for different clients. So the accounting firm might be interested in knowing that whether that information, whether the historical information about the auditing of these financial reports, whether that can be used to find out the potential fraudulent reports, potential fraudulent statements, and that can make their task of auditing much easier, because they can do more intense inquiry on few identified records, few identified reports or statements, right. So where the fraudulent, the chances of the reports being fraudulent are more likely. So they would like to identify those reports where the chances of those reports being fraudulent are on the higher side. So let's say we have 1000 such reports. So this is sample size is 1000 such 1000, and the variable from the historical information of their clients, the accounting firm's clients, that we have is whether that particular client had a prior legal trouble or did not have prior legal trouble, whether in previous years the reports submitted by those clients, whether that was found to be problematic and therefore they had some legal trouble, or they did not have any legal trouble. So with that information can we identify the some of the fraudulent reports and or identify the truthful reports. So this classification matrix or this based on the data set also we can produce this kind of summary table using a pivot table option that we have in Excel. So this kind of summary stat we can easily generate using our data. So you can see this side we have prior legal, this is the predictor, this is just one predictor that we are using here, and as we talked about, if there are more number of predictors, as we talked about, the chances of finding exact matches always go down, right. So here this is x1, so that means prior legal trouble, x value as 0, this is no prior legal trouble. Then we have whether the report was fraudulent or truthful. So 50 fraudulent reports they had prior legal trouble, 50 fraudulent reports they did not have prior legal trouble, 180 truthful report they did not have a prior legal trouble, and 720 truthful reports they had no prior legal trouble. So this is the hypothetical example that we have, and then totals for all these scenarios have also been done. So now from this we can actually compute some of the conditional probability values that we talked about. For example, probability of a particular record belonging to fraudulent class, that is C1, and given the prior legal trouble, that just one predictor that we have, in this case prior legal trouble, given that information, probability of a particular record belonging to the fraudulent class would be 0.22 computed by using these numbers. 50 times 50 reports have been fraudulent reports also had prior legal trouble. So this is the number 50, and then divided by the 230 total reports which had. So out of total reports, that is 230, which had prior legal trouble. 50 of those were also identified as fraudulent. So, conditional probability would be can be computed using these two numbers. So, this comes out to be 0.22. If we want to compute the probability of a particular report being truthful given the information we have related to prior legal trouble, so this also can be computed. So, out of all the records, which had all the reports which had prior legal trouble, that is 230, 180 were found to be truthful. So, the conditional probability would be computed using these numbers, 180 divided by 230. So, this will give us the probability of a particular record belonging to truthful class given they had the prior legal trouble. So, this number comes out to be 0.78. So, if we apply the most probable class method here, right. So, most probable class method would say that among these, so once those records, as we talked about these steps, once those records having exact matches have been identified, then we will have to compute the most prevalent class among those records so we already have the information related to probability of different classes, so whether fraudulent or truthful. So, we have 0.22 and 0.78. If we look at the higher number, it being 0.78. So, if we apply the most probable class method, then based on that 0.78 being the higher value, so the record new observation would be classified as the truthful report, right, truthful report. So, most probable class method would lead to this conclusion. So, this whole example is quite simple in this case, because we are dealing with just one predictor information, right. Now, if we apply a different approach, the cutoff probability method. So, suppose we are interested in one particular class. So, we have a class of interest. So, in this particular case, the class of interest is typically going to be the, as we discussed about the problem, typically it is going to be the fraudulent reports. So, we are more interested in identifying the fraudulent financial reports, because we will like to do more intense scrutiny of such reports as an accounting firm. So, therefore, we are more interested in identifying such reports. So, the class of interest is the fraudulent class. So, for this we will have to specify the cutoff probability for this class of interest. So, let us say the cutoff probability is 0.2 as indicated here. So, if this is the established user specified value. So, any probability value that we compute following those steps, finding the records from the training partition which are having the exact matches. So, this particular step we do not have to perform in this example. And then the second one being identifying the most prevalent class, right. So, that we can do the probability values we have using the information that we have here for this example. So, if the cutoff value is 0.2, and if we compare it to compare this one with the computed probability value, which is 0.22. So, you can see that the probability value is greater, 0.22 is greater than 0.2. So, in that case, the new observation is going to be classified as the fraudulent class, right. So, you can see depending on the method our answer might change, because the cutoff value for a class of interest can actually be specified by the user, because we are interested in one particular class, right. In the typical regular case where we do not have, we would like to minimize the overall error. So, there we would just go with the majority rule or the most prevalent class. In that case, as you can see, the observation would be identified as the truthful. The for M class scenario, the formula that we talked about, the conditional probability formula that we talked about is can be expressed using this particular expression. So P probability of a particular observation belonging to class I, class Ci, given the predictors information x1 to xp. This conditional probability can be computed using this. In the numerator, we have probability of x1, x2, xp, probability of those predictors value given the particular class Ci, and this multiplied by the probability of a particular record belonging to Ci. Then in the denominator, we have for every class, for example C1, we have the same expression, probability of a record belonging to this particular predictors values, and given it belongs to class 1, and then multiplied by the probability of belonging to class 1, then for all the classes, and that is how the denominator would be there. So this is the typical conditional probability formula that you might have studied in your previous degrees in 10th or 12th or during your graduation. So using this particular conditional probability, we can find out the exact probability value, and then that can be used to find out the prevalent class, and then or can be used to compare with the cutoff user specified cutoff value in case of class of interest. So you can see in the when we have just one predictor, it is quite easy for us to perform these computations and then do your comparisons and follow the steps, and therefore do your classification. But what we are talking about is the finding exact matches, right? For the new observation, we will have to find out the records which are having the same predictors value. Now this becomes quite difficult if the number of predictors increase, right? So for an example, if in a university we have to find out a person who is doing a BTech in a particular engineering, let's say computer science and engineering, and then he might have also taken an elective on data analytics, and then his CGPA would be some 7.8 or something, or more than that, or 7.8 exactly, if all that grade in that particular subject, because we are talking about all the predictors being categorical. So and then whether that particular student being male or female, or belonging to a particular city or state. So as we keep on increasing the number of predictors and the values, so it would become more difficult for us to find exact matches, as the number of predictors, even though these predictors are categorical, so they will have the classes, they will have the labels, right? So even for a limited number of labels for a particular predictors, as the number of predictors increase, it will be very hard to find the exact matches. So therefore that becomes the practical limitation of applying complete or exact Bayes. So as you can see in this particular slide as well, complete or exact Bayes limitation for a model even with a small number of predictors, many new observations to be classified might not get exact matches, right? So as we talked about with an example, that even if we have a small number of predictors, we talked about only 4 or 5 predictors: the gender, the city, the hometown, gender, hometown, and the program, the undergraduate program that he or she might have might be enrolled to, then the particular course that he or she might have taken, then the grade in that particular course. So 4, 5, 6 variables, and even with these variables you would get the idea that it becomes quite difficult out of thousands of students that might be in the campus, with the specific details that I have given. If I give the name of the city, if I give the engineering that he or she might be doing, student might be doing, and then if I take a name of an elective course that he might be studying, and a particular grade within that for that course, the gender information, then you would see we will end up with out of so many students, 10,000 students, we will end up with just 10 or 5 students, or 10, not even 10, because they have to come from the same city, hardly 2 or 3 students. So the number of exact matches with just 5 or 6 variables, they come down to such a small number. So hard to find exact matches, and therefore many probability values will not be able to compute. Therefore, how are we going to classify the new observation? If there are no exact matches, we won't be able to classify, because we need to find the exact matches, and then within those matches, then we need to find out the most prevalent class, right? And even then, if we are able to find the exact matches and there are very few exact matches, then the classes might not be, all the classes might not be covered, all the probability values that could be there because of the few exact matches, they might not remain meaningful, right? So the idea is there should be a lot more matches, so that the values that we get, they are slightly stable given the sample, given the problem, and so that our classification might be more accurate and will not be dependent on the data, and those results should be more stable. Our classification results should be more stable. So we need more matches. Fewer matches, even if we find matches, if they are very few, that could also be problematic. The next point in the limitation is the probability of a match might reduce significantly on adding just one variable to the set of predictors. So if we add just one additional predictor in the set of predictors, and that one predictor, even if it has just 2 classes, right? So that those classes are the frequency of those classes that is equal, in that case equally occurring with equal frequency, classes occurring with equal frequency, then that would reduce the number of exact matches by the factor of 2, right? 2 classes by factor of 2, it will reduce the probability of finding a match. So therefore, if we include a predictor and it has more than 4 or 5 classes, then that would reduce the probability of finding exact matches by factor of 5, right? So therefore, the complete or exact base, so because of these limitations, it is quite difficult to apply complete or exact base for our modeling exercise. So what is the solution? Solution is the neo base, some assumption, some simplification of complete exact base that we perform, that allows us to apply our base modeling on for different classification problems. So we'll stop here and we'll continue our discussion on neo base. Thank you.